Hi everybody! In this video I will talk about this Ev3 Metro dashboard from Budapest Metro Line 2. As you can see, it's missing a few parts. I will have to build the missing panels, levelers and gauges, but for the switches I have a few spare parts. Let's see what we need for reworking such a dashboard to work in a simulator like LOTUS or even in OMSI. First and most important is a microcontroller, in our case an Arduino Duo. We also need a power supply for some components. For the lights I will use 24 volts. This is the adapter of a Logitech DFGT steering wheel. For the converters and other ICs we need 5 volts. I will do that with this little step down. This will convert the 24 volt to 5 volts. Let's see the electronics. I will start from the easier ones. First we have our barometers. Somehow we have to drive them, and of course I won't use 8 to 10 bar high pressure in the room, so we must use stepper motors. I will use X27 168 steppers like this one here. These are industrial used stepper motors. They are used in car dashboards. These are made for moving the needles of gauges. They have pretty low power consumption, so we can drive them from the microcontroller itself. Also there's a library for the Arduino. We need 4 wires to connect the stepper to the Arduino. It's easy to calculate, we all in all need 12 wires for that. We also have a few warning lights. This is a bit more difficult. Here the problem is that we have to drive the 24 volt lights from the Arduino, which is not possible. What I'm going to do first is to separate the Arduino ground. This is only a safety thing. I simply don't like when the power supply ground is connected to my PC motherboard ground, which is common with the Arduino ground through the USB cable. It's not likely that it could cause any harm, but I still don't want to give any chance to ruin anything, so I will use optocouplers for that reason. Of course, these cannot handle large currents, and also they need 5 volt supply. To drive a light bulb with these, we need some relays or MOSFETs. The relay modules are easy to use, but I don't like their clicking noises very much, so I will use FETs for this purpose. Of course, we need a gate resistor too. Anyway, we use the FET to switch on and off the bulb to the 24 volt supply. What's an optocoupler? It's a little integrated circuit, maybe you can see it on the image. Of course, we need series resistors, otherwise the LEDs inside them will burn to ashes. Also, we need some FETs. Probably you won't even see them on the picture well, but otherwise it's a simple free leg transistor. About the speedometer. Well, it's missing from the dashboard as you could see, so I have to build one from scratch. I will use a 2x7 segment LED display. It's got a yellowish green color, similar to the original ones. It's also about the same size. Practically, it has a lot of pins. One for the 7 digits and one for this little dot here, which I won't use. So we can control the 7 segments one by one, and in this particular type both numbers have their own supply pin. Technically all we have to do is to switch the ground to the pins from A to F. I will drive these segments with a Bcd converter like this. Its job is to... maybe it's easier to show on a paper. We have 4 inputs. With BCD we can represent numbers from 0 to 9. Of course we won't use the numbers from A to F. The IC will convert that for the 7 segment display. This way we don't have to use 14 different wires from the Arduino, so we can save outputs like this. Technically I will still use optocouplers for all the 2 times 4, so 8 wires from the Arduino to separate the grounds. After that, the signal goes into the converter. We have 2 displays, so we have 14 signals, which we have to send to the FETs. The reason is simple. These converters should be able to drive the LEDs by themselves, but it's already on the threshold, so we gotta use transistors instead. Since this type of display has a common anode, which is the positive node, all we have to do is to switch the negative pins to the ground to control the segments. Here is the beautiful circuit of the speedometer. All of the needed components are on this PCB. Here are the optocouplers I mentioned earlier. Here are the inputs from the Arduino. Here are the 2 BCD converters, which will drive our display. Here are the FETs. This little step-down module converts the 24 volts to 5 volts. And of course, this charming little piece of art is the speedometer itself. Let's talk about the barometers. Both of them are MP2 barometers. This one is in fact an MP2, and this one is an MP2 U2 gauge. You can see that this is a gauge with 1 needle. It measures the brake cylinder pressure. Its scale is from 0 to 6 bar. As you can see, it's quite Soviet made. And this one is for the brake line and mainline pressure. This has 2 needles, a black and a red one. Let's have a look inside of them. Fortunately, our fellow Russian engineers used screws to assemble the gauges, so we don't need to use brittle force to disassemble them. Let's first see the brake cylinder pressure gauge. As you can see, there's a C or half moon shaped chamber. This is the so-called Bourdon tube. When pressure is applied to it, it tries to expand. So it tries to change its shape like this, and its end is connected to the needle with some gears. By the way, this is a pretty common pressure gauge layout. It's still used nowadays. It's not a big surprise that the two needle gauge works the same way. The only difference is that it's got two Bourdain tubes. Here you can see it. Of course they are stiffer because they are calibrated to 0 to 16 bar and not from 0 to 6 bar. But still it's the same principle. Our task is to drive these barometers from a simulator with our PC. Well, of course I won't use an air compressor and EP switches, since that would be a nightmare. With the one needle gauge it's easier. You can see that we have to use the stepper motor to rotate the needle. Here it's an easier job, because if we remove the mechanics, we can attach a needle to the motor, and we can attach the stepper motor to the dial of the meter. But this will definitely not work with the two needle gauge, since it's a more complicated mechanism with two shafts inside each other. Here we have to use some tricks. Of course there are a bunch of ways to do it. Let's see the finished gauge structures. This is our brake cylinder pressure gauge. It only needs its needle, and I have to rearrange the wires somewhere. The two needle gauge was more complicated, because here we have to use two steppers. For this purpose I made this horrible mechanism with 3D printed gears, where each motor drives one of the axles with a simple transmission. Of course I still have to rearrange the wires somehow, because this way it won't work. But that's the basic principle of these barometers. In the meantime, I've worked on the controller handle with this marvelous, very DIY-ish LED. I don't recommend this to anyone. You should really ask someone who has the needed machines. But still, I want to point to something important. Even if you use a LED, a drill stand, anything, you should definitely use some safety goggles, not just when you work with metals. No hobby is important enough to harm your eyesight. Anyway, for the controller handle I used a real one from an EV metro car as a template. The one in the EV3 type has a wider base, but that's good enough for rough sizes for now. Besides its DIY style, it's not half that bad. And probably it will even look better when painted. Here's the final product. Without any accurate information nor pictures, I made the side panels to look like this. I still think that they more or less represented the real dashboard. At the moment, these switches here don't really have a purpose, but of course they are functioning. I know it's completely wrong, but I use this button for the enhancements. It's just simpler to use. Of course I know that in real life the co-driver operated it on the left side of the driving cab. Let's first see the brakes. Now it's in closed state. And with full braking, so this way the brake line is emptied fully. At charging it releases slowly. At first fast release, of course, it can overcharge the brake line from the main line. Please ignore the inaccuracy of the needles. It's pretty hard to make a precise mechanism with 3D printed gears and so on. Of course, I still have to fine-tune these. Among the meters, only the current meter is working. The network voltage meter is stuck at this position. Of course, the third rail is not at 300 volts. The battery voltage meter is also broken. But this little guy works just fine in the game. And as expected, the gauge lights work too. In the end, I used 24 volt 2 watt light bulbs connected in parallel. Among the warning lights, we have an RP red, an RP green, a door fault signal and the 2 door open signals. All of them work, but in Lotus only the RP red and the door lights are used. Please ignore the flickering TV screen, I have absolutely no idea why it's doing that. Maybe the cable is faulty or the PC connection. Of course, if we step down in brake 2 position, the first EP valve will switch on the last brake position. Also, here's our speedometer with wonderful homemade electronics, spiced up with some white plastic. And finally, let's see how it works in-game.
Szíveskedjenek vigyázni, az ajtók záródnak. A Moszkva tér következik. Tessék vigyázni, az ajtók záródnak. A Beat Ferenc tér következik. Beat Ferenc tér. Szíveskedjenek vigyázni, az ajtók záródnak. Az Astoria következik. Astoria. Tessék vigyázni, az ajtók záródnak. A Blaha tér következik. Blaha tér. Szíveskedjenek vigyázni, az ajtók záródnak. A keleti pályaudvar következik. Tessék vigyázni, az ajtók záródnak. A stadionok